Welcome back. In this video, you will learn about exact matching for assets and liabilities. Let's get to it. All right, so when conducting a business, an individual or corporation will commit to making payments and receiving payments in the future at various points in time. And to keep the business running or to even be profitable, it's in the individual or corporation's best interest to make investments so that they have funds available to use for outgoing payments as they become due. In other words, you want to have money available to make payments in the future so that you're not in debt. Now, we call these outgoing payments, or money that you owe, liabilities, and we represent a liability at time t with this notation, capital L sub t. That represents a liability or an outgoing payment that is made at time t. Now, the incoming payments, or the investments and funds available to pay for these liabilities, are called assets, and we represent an asset available at time t with this notation, capital A sub t. That represents the amount of an asset or incoming payment at a particular time t. And so with this lesson and the next lesson, we're going to focus on a couple different ways that an individual or a company could manage their assets and liabilities. And the first method, which is the topic of this video, is referred to as dedication, or more commonly, and the way I'm going to refer to it, is exact matching. And the idea of asset-liability exact matching works like this. If an individual's investments, or the investments for a company, can be arranged such that the assets exactly cover the liabilities due at each point in time t, meaning that A sub t is equal to L sub t for every time t, then we would say that the assets and liabilities are exactly matched. And so let me show you what I mean by that. If we take a look at this timeline here, we're starting at the present day, t equals 0, and then we have t equals 1, which is 1 period in the future, then t equals 2, which is 2 periods in the future, and t equals 3, which is 3 periods in the future. And now on the top of the timeline, we have our assets, A sub t, so at time equals 1, we have A sub 1, then at time equals 2, we have A sub 2, and at time equals 3, we have A sub 3. Then below the timeline, we have our liabilities. At time equals 1, we have L sub 1, at time equals 2, we have L sub 2, and at time equals 3, we have L sub 3. And once again, the assets represent incoming payments, and the liabilities represent outgoing payments. All right, so if these assets and liabilities for this timeline, or for this scenario, are exactly matched, what that means is that at each moment in time, the asset is equal to the liability. So for this timeline, if these assets are exactly matched to these liabilities, then at time equals 1, A sub 1 would be equal to L sub 1. At time equals 2, A sub 2 would be equal to L sub 2. And at time equals 3, A sub 3 would be equal to L sub 3. All right, so that's the idea of exact matching. Each of our assets, A sub 1, A sub 2, and A sub 3, are going to be equal to the corresponding liability at each of those times. L sub 1, L sub 2, L sub 3. All three of these equations need to be true to say that these assets and these liabilities are exactly matched. Okay, now that's really all there is to the concept of asset-liability exact matching. You just need to know that at each moment in time, the assets should be equal to the liabilities. It's really not any more complicated than that. All right, so now that you've been introduced to this concept of exact matching for assets and liabilities, let's take a look at an example problem where we will use the exact matching method. Okay, so here's our example. We have that a company has a $75,000 liability due in 1 year and a second liability of $203,300 due in 2 years. The company has two types of bonds, A and B, that they can use to match these liabilities exactly. Bond A is a 2-year $1,000 par value bond with 7% annual coupons, and Bond B is a 1-year 0 coupon bond redeemable at $1,000. Given all this information, we want to know how many of each type of bond should the company purchase in order to match the liabilities exactly. And then additionally, we want to determine the cost for matching the liabilities exactly if the effective yield rate for both bonds is 5% annually. Now, we'll worry about that second question later. For now, we just want to focus on the first question, which is how many of each type of bond should the company purchase in order to match the liabilities exactly? In other words, we want to match our assets and liabilities in this problem exactly so that each asset and liability at each moment in time are equal. Okay? And so the first thing that we need to do here for this problem is identify the liabilities for the company and the assets that are available for them to use. So let's start with the liabilities. We're told what the liabilities are right away at the beginning of this problem. The company has two of them. They have a $75,000 liability due in 1 year and a second liability of $203,300 due in 2 years. And so let's draw out a timeline here that consists of 2 years. I'll start with time equals 0 right here, and then let's draw the timeline. Here is time equals 1 and time equals 2, and I'll label them. This is t equals 0, t equals 1, and t equals 2. Now I'm going to place the liabilities below the timeline, so we'll have L sub t, or the liability at time t, down here below the timeline, and then we'll place our available assets up top. All right, so the assets A sub t will be above the timeline. Okay, so the company has a $75,000 liability due in 1 year, so that's going to be the liability at time equals 1. So L sub 1 will be $75,000, and then the company has a second liability of $203,300 due in 2 years, so the liability L sub 2, or the liability at time equals 2, will be $203,300. So I'll write in $203,300. Okay, so those are the two liabilities that we have to work with in this problem. But now let's take a look at the available assets for this company. If we go back to our problem, the company has two types of bonds, A and B, that they can use to match these liabilities exactly. So essentially these bonds, A and B, are acting as our assets. They are the incoming payments that the company can use to pay off these liabilities in the future. All right, now bond A is a 2-year, 1,000 par value bond with 7% annual coupons, and bond B is a 1-year, 0 coupon bond redeemable at 1,000. All right, now remember, we don't actually know how many of each of these bonds the company has. We just know what these bonds are. We need to determine how many of each type of bond the company needs to purchase to exactly match the liabilities to those bonds or to those assets. All right, so we don't know how many of each we need, so I'm going to introduce a variable to represent the number of those bonds that we need to purchase. So I'm going to say that the number of bond A that we need to purchase, or that the company needs to purchase, will be represented by X, and that the number of bond B that the company needs to purchase will be represented by Y. So what we're going to end up doing in this problem is solving for these two variables. We want to know what X is equal to and Y is equal to, which represent the amount of each type of bond that the company needs to purchase. All right, so we're going to use these variables when we write out the amount of the assets at each moment in time. All right, so for bond A, that is a bond that has 7% annual coupons. So that means that there will be a coupon paid at time equals 1 and time equals 2. But since the bond is only a 2-year bond, the redemption amount, or the face value, will also be returned at year 2. So we'll have a coupon at time equals 1 and a coupon and the face amount at time equals 2. All right, so let's determine the value of the coupon for bond A. We have a 7% annual coupon rate. So we'll take the $1,000 par value, multiply it by 0.07, that is 7% in decimal form, and 1,000 times 0.07 is $70. So bond A has annual coupons of $70. So if the company purchased one bond A, they would receive $70 at time equals 1. So we'll write that in. We have $70 at time equals 1. And then there would also be a payment of $70 or another coupon at time equals 2. But we would also include the redemption amount, or the face value, which is $1,000. So we'll have a total of $1,070 that is paid at time equals 2 by bond A. All right, now these two values, $70 at time equals 1 and $1,070 at time equals 2, are the amounts that would be paid if only one bond A was purchased. But we don't know how many the company is going to buy. We want to determine that. So we need to multiply 70 and 1,070 by X, the number of bond A that is purchased, and that will accurately represent how much would be paid at each moment in time given a certain amount of bond A's, right? So we'll multiply 70 by X and 1070 by X as well. Okay, now we can do the same thing for bond B, except bond B is a little bit different because bond B is a 1-year zero coupon bond redeemable at 1,000, and a zero coupon bond means that there's no paid coupons. It's just that you receive the redemption amount or the face value at the maturity of the bond. And in this case, bond B is a 1-year bond. And so really the only incoming payment that will come from bond B is a payment of $1,000 at time equals 1, right? So we'll have $1,000 at time equals 1 for bond B. But depending on how many bond Bs are bought, this could be 2,000 or 3,000 or 4,000 and so on. So we need to multiply this 1,000 by the number of bond B, which we represent with Y. So 1,000Y will represent the amount paid by bond B depending on how many of those bonds are purchased. Okay, and so with that, we have now accounted for all of the incoming payments or assets that this company could have depending on how many of bond A and bond B they purchase. Okay, so at time equals 1, the combination of 70x and 1000y would be A sub 1, or the asset available at time equals 1. And then at time equals 2, the asset available A sub 2 would be 1070 times x. And so if we want to exactly match these assets to these liabilities, what needs to be true? Well, 70x plus 1000y, whatever the total of this asset at time equals 1 is, that needs to be equal to this liability at time equals 1, right? So we can set up an equation here. We would say that 70x plus 1000y needs to be equal to 75,000. If the assets and liabilities are to be exactly matched, then the sum of the assets at time equals 1 needs to be equal to the liability at time equals 1, which is what we have just written right here. And in the same way, the assets at time equals 2 should be equal to the liability at time equals 2. So we can set up a second equation that 1070x should be equal to 203,300. So let's write out that equation as well. We'll have 1070x is equal to 203,300. Okay, so if the assets and liabilities are exactly matched, the asset at time equals 2 should be equal to the liability at time equals 2. And so what we have now is a set of equations that we can use to solve for x and y. Right, at this point, all we have left is just a very basic algebra problem. We have two equations and two variables. We just need to solve for the value of both of those variables. We'll solve for x, and that will tell us the number of bond A that needs to be purchased, and we'll solve for y, which tells us the number of bond B that we need to purchase. At least the number of each of those bonds that we need to purchase in order for the assets and liabilities to be exactly matched. And so let's do that. Let's solve for x and y in these equations. Now I'm going to start with this second equation here because we can solve for x pretty easily. All we have to do is divide both sides by 1070. So if we do that, we'll find that x is equal to 203,300 divided by 1070. And that's actually equal to a nice number. It comes out to exactly 190. So x is equal to 190. I'll write that up here. We now know that x is equal to 190. And then we can solve for y because we now know the value of x. We can plug this value of 190 into this equation and multiply it by 70 and then solve for y. So if we do that, we'll have 70 times 190 plus 1000 times y, and that is equal to 75,000. And 70 times 190 is $13,300. And so that would be added to 1000y, and that's still equal to 75,000. But in order to solve for y, we will need to subtract that value from $75,000. We need to subtract 13,300 from both sides of the equation. So I'm going to do that right away, and we'll just have that 1000y is equal to $75,000 minus 70 times 190, which was 13,300. And so subtracting that from 75,000 will give us $61,700. Okay, and then to solve for y, we just have to divide both sides by 1,000. And if we do that, we will find that y is equal to 61.7. And that is an exact value right there. 61,700 divided by 1,000 is 61.7. Okay, so now we have solved for x and y in these two equations, which means that now we know the number of bond A and bond B that the company needs to purchase in order to exactly match the assets and liabilities. In order to exactly match the liabilities and the assets, the company needs to purchase 190 of bond A and 61.7 of bond B. And so that would answer the first part of this question, right? We wanted to know how many of each type of bond should the company purchase in order to match the liabilities exactly, and we have now found that. So now we can move on to the second part of this question, which is to determine the cost for matching the liabilities exactly if the effective yield rate for both bonds is 5% annually. All right, now in order to determine the cost for matching the liabilities exactly, all you have to do is determine the present value of the liabilities or the assets. You can calculate either present value, it doesn't matter. They're both going to be the same. If the assets at each moment in time are equal to the liabilities at each moment in time, then both of their present values should be the same. The value of the assets and the value of the liabilities at time equals 0 will be exactly the same. And that value will be the cost of matching the liabilities exactly. Okay, so all we have to do to calculate the cost is to calculate the present value for one of these two sets of cash flows. All right, now if you were solving this problem yourself, you only need to do it one way, but I'm going to show it both ways just so that you can see that you will get the same answer either way. And so I'm going to start by calculating the present value of the liabilities. The present value will be equal to 75,000 times the present value factor to the first power plus 203,300 times the present value factor squared. All right, in order to find the present value of these two cash flows or these two liabilities, we need to take this liability of $75,000 at time equals 1 year back to the present. So we have a present value factor to the first power. And in the same way, we need to take this liability back 2 years, so we multiply it by the present value factor squared. All right, now you can plug this into your calculator, but you might be wondering, well, what is the effective interest rate? What is the value of I for both of these present value factors? Because remember, v to the power of t is equal to 1 divided by 1 plus I to the power of t, where I is the effective interest rate. In this case, we're told that the effective yield rate for both bonds is 5% annually, so we know that I is equal to 0.05. All right, that is 5% in decimal form. So if you use that value of I for both of these present value factors and plug this into your calculator, the present value of the liabilities, which is the cost of matching the liabilities and assets exactly, will be $255,827.66. That is the cost of matching the assets and liabilities. It is the present value of the liabilities, but it will also be the present value of the assets. And so let me show you that you will get the same answer if we calculate the present value of the assets. All right, so I'm going to keep this answer on the screen, but now let's calculate the present value of the assets and compare. The present value of the assets will be equal to the assets at time 1 times the present value factor to the first power. So we're going to have 70 times x, but remember, x is equal to 190. So we have 70 times 190 plus 1,000 times y, and y is 61.7. So we multiply by 61.7, and those two assets added together give us the total of the amount of asset at time equals 1. So both of those amounts need to be multiplied by the present value factor to the first power, and that will be added to the asset at time 2, which is 1,070 times x. So we'll have 1,070 times x, which is 190. So we'll write 190, and that will be multiplied by the present value factor squared. Okay, so now remember, the yield rate for both bonds is 5% annually. So for each of these present value factors, we're still going to use I equals 0.05. Just know that if these bonds did have different interest rates, that you would need to be careful on how you calculate this. If they had different interest rates, you would actually need to split up this right here, because 70 times 190 corresponds to bond A, and 1,000 times 61.7 corresponds to bond B. So if they had different yield rates, you would still multiply both of these amounts by the present value factor to the first power, but you would need to use their respective yield rates. So you would get rid of these parentheses and just individually multiply each of these assets by the present value factor to the first power and use their respective interest rates. But in this case, it's going to be the same. It's 0.05, so you don't really need to worry about that. But either way, if you plug this into your calculator, you will get the exact same value that we got up here. You will find that the present value is equal to $255,827.66. That is the present value of the assets, and it's also the present value of the liabilities, but what it really represents is the cost of matching the liabilities exactly. Okay, so that's it for this example. We have now answered both of the questions that we needed to answer. We found how many of each bond the company needs to purchase to exactly match their liabilities and assets, and we also determined the cost of that exact matching. Okay, and so that's really all you need to know about asset liability exact matching. But if you want to see some more examples, feel free to check out my examples video that I'll have linked at the end of this video, as well as in the description below. If you have any questions, feel free to leave those in the comments. But if you don't have any questions, this is all I had for now. So I will see you next time.